Hello and welcome. This lecture represents a pivotal moment in the course, as we will be adding authentication and authorization support to our website. This means that we will be able to decide which parts of our websites are publicly accessible and which ones requires users to log in and have specific roles to access them. We will start by introducing Spring Security. We will then create a new feature branch where to write the code for this lecture. Then, we will set up Spring Security to handle in-memory authentication and authorization. We will then update our website to support Spring Security. Finally, we will close the Git flow workflow by merging our work to the develop branch. At a very high level, Spring Security is a servlet filter which intercepts every request made to the website. Then, depending on how it has been configured, it will either allow the request through, for example if the content is public, or it will send an unauthorized response back to the browser, which we will then ask the users to authenticate. Once a request passes the Spring Security filter, it behaves as normal. Spring Security is an independent Spring project, and there are various ways it can be set up. Before Spring Boot, we as developer had to do a fair bit of work to set security up. Spring Boot makes it a breeze, as a lot of boilerplate configuration is taken care of on our behalf. Before we can set up Spring Security, let's clarify a few important concepts related to web security in general. Authentication is the process by which users inform the application of who they are. This is typically achieved by entering credentials on a form. Authorization is the set of roles that the user assumes when logged in. These roles can then be used to fine-grain what users can and can't do. Basic authentication is a basic authentication protocol based on username and password credentials. Basically, once users enter their username and password credentials in a login form, these are sent as username : password using a base64 encoding and then set into a header with a format similar to the following: authorization, basic, and then the base64 representation of the user's credentials. Additionally, as a word of warning, production applications should run over HTTPS, which encrypts the content exchanged between clients and servers, so that a malicious attacker cannot decipher sensitive data unless they are in possession of the private key. We will not set up HTTPS as part of this course due to the high costs involved in obtaining a trusted certificate. However, if you intend to build a commercial website from the DevOps Buddy skeleton, you should really consider purchasing a trusted certificate and running via HTTPS. Armed with the knowledge around some basic security concepts, let's see how we can set up Spring Security for the DevOps Buddy application. The first thing we need to do is to create a feature branch. As usual, let's start by making sure we are pointing at the develop branch with the git command git checkout develop. Then, we can create a new feature branch called the security with the git commands git checkout -b security, git push -u origin security. The first thing we'll do is to add the Spring Boot security dependency to the pom.xml file. We can do this by opening the POM and adding the Spring Boot starter security dependency. If we restart our application now and visit localhost 8080, we can see Spring Security in action. We are challenged with a basic authentication form, which asks for username and password. This is because, by default, Spring Security protects all requests to our website. For things to work properly, we need to set it up so that it allows access to public content and protects everything else. Let's see how we can do this. We will create a new configuration class and name it Security Config. We can do this by right-clicking on the config package and selecting New Class and then providing the Security Config name. This class needs to extend the Web Security Configurer adapter class so that we can take advantage of its existing functionality. As usual, first we will annotate this class with the @configuration annotation. For Spring Security, we will additionally annotate it with the @enable web security annotation to activate Spring Security for our MVC application. I'm now going to copy some code I've prepared for this lecture, and then I'll talk you through it. First, we have declared a constant array of strings, which contains all the publicly accessible URLs. Because Spring Security protects everything by default, we need to be very precise about the content we want to be public. With this constant, we have declared as public the following content. All web jars. These contain the Bootstrap and jQuery libraries that we have set up in previous lectures. All static content. This includes CSS and JavaScript files, as well as images. The home page, the About and Contact Us pages, any errors that might occur. We have then defined a configure global method which accepts an authentication manager builder. Because we have declared the Spring Boot security dependency, this bean is already made available to us by Spring. All we have to do is to annotate the method with the @autowired annotation, so that Spring injects an instance of this class as method parameter. In this method, we set the configuration to be in memory, we set up a user and a password, and we assign a default user role to that user. We have then overridden the configure method from the Web Security Configurer adapter class and set up the security model. Basically, we are saying, authorize all HTTP requests. Don't require authentication for all public matchers which we have defined as a constant above. Authenticate everything else. Use a form login for authentication and specifically use the one that we have created. If users are logging in after clicking on the login link, after successful authentication, direct them to the /payload URL. For any login failures, send a GET request to the login URL with the parameter error. Finally, allow anyone to log out without asking for authentication. By default, Spring Security handles the logout request for us, and if successful, it redirects to the login URL passing logout as parameter. If we restart the application now, we can see that the Home, About, and Contact Us page all display without asking for authentication. However, if we enter the URL localhost 8080/payload, we are redirected to the login form that we have created in one of the previous lectures. We can enter user as username, password as password, and we will be shown the payload page. This is great. However, there are still few things we need to address. First, we will add the Spring 4 security dialect for ThymeLeaf. We can create a new section in the pom.xml file and add the ThymeLeaf extras Spring Security 4 dependency. I'm using version 2.1.2 release. Feel free to use the same. Then, we need to make few changes to our navbar page. We want the login link to appear only for users who haven't logged in yet. We also want the logout button to appear only if users have already signed in. Let's see how we can do this. I'm going to replace the navbar write code with some code I've prepared for this lecture. Please feel free to pause the video and follow exactly what you see on the screen step by step. We have introduced a new ThymeLeaf attribute named thif. This attribute does what it says on the theme. If the expression evaluates to true, it displays the children elements, otherwise it doesn't. With the dependency that we have just added to the POM file, ThymeLeaf now understands Spring expressions, commonly referred to as spell. Notice how we have written a spell expression that says, if the user is not authenticated, display the login link. We have also defined another if condition for the logout button. Here we are saying, if the user is authenticated, then display the children elements. For the logout functionality, we have defined a form, since the logout action must be a post to be correctly handled by Spring Security. Within the form, we have defined a button of type submit with the text attribute set to navbar.logout.text, to which we assign the value logout, and the Bootstrap class btn primary, so that it appears in blue. We will also change the logging for the org Spring Framework security package in the logback.xml file to debug. This is useful for you to understand what Spring Security does during execution. If you look at the log messages printed to the console during execution, you should have a pretty good idea of what Spring Security is doing. The last thing we need to do is to make some changes to the login form so that it can display a feedback message to the user in case of incorrect login or when the user decides to log out. I'm now going to copy some code to the login.html page Please pause the video and take your time to copy exactly what you see on the page. Here, we are creating a new Bootstrap row within the container, and we want it to be centered like the form. Again, we are using the ThymeLeaf thif attributes to display a message to the user. If the supplied credentials are wrong, which means that Spring Security invokes the URL login passing error as parameter, we want to display a red error message to the user with a little X on the top right to close the window. We can achieve this by using the Bootstrap class alert danger and alert dismissible. The error message has been defined in the text property login.error.message, to which we are going to assign the value an error occurred while logging in. Similarly, we want to display an informative message, in green this time thanks to the Bootstrap class alert success, when users have logged out successfully. The successful logout message has been defined in the text property login.logout.success, to which we are going to assign the value you have successfully logged out. Finally, we want to keep our messages.properties file nice and tidy. We will move the login messages to the login section and the navbar message to the navbar section. We can see the result of our changes when restarting the application. First, the Home, About and Contact Us pages work without any authentication required. We can see the login link on the navbar top right. If we click on it and login, the link will disappear and the navbar will show the logout button. If we click on it, we can see from the logs that we have been logged out and we have been redirected to the login page, only this time we will see a nice message. We can try to access the payload URL and then clear the console messages. If we enter incorrect credentials now, for example by entering a random password, we will see in the logs the steps followed by Spring Security. Look for the string authentication failed, password does not match stored value. If you follow the logs, you will notice that Spring then forwarded to login ? Error, which is why we were able to see the error message in the console. The last topic I wanted to discuss is Spring Security native support for cross-site request forgery, commonly referred to as CSRF. If we restart our application and click on the login button, we will see the login form. Now, let's look at the HTML source. If you look towards the end of the form, you will notice an input element of type hidden, with the name _CSRF and a certain value. We haven't added this element to our login form, so how did it get there? Spring Security and ThymeLeaf have added it automatically to the form for us, thanks to the @enable web security annotation. So what is CSRF? Imagine that we were redirected to a malicious website after logging into the DevOps Buddy website. Here, a page could have retrieved our authentication details and submitted the request to the DevOps Buddy on our behalf. To prevent this, we need the ability to provide an identifier that other websites can't provide. This is what the Spring CSRF support does. Wow, we've gone through a lot in this lecture. I told you guys that as the course progresses, we would go more and more through interesting topics. Now we have in-memory authentication and authorization in place. We have learned how to set up Spring Security to protect certain content and leave other content publicly available. We have learned the thif attribute and the ThymeLeaf support for Spring Security dialect. We have learned how to check whether a user is authenticated and display content accordingly. We have learned about the login and logout functionality and how to increase the logging level for a particular functionality we want to check. Finally, we have learned about CSRF and how Spring and ThymeLeaf enable it by default. Before closing this lecture, we need to complete the Git flow workflow as usual. Let's push the current code remotely with the Git commands git add * git commit -m enabled Spring Security for the website and git push. Then we need to merge the security branch to the develop branch with the git commands git checkout develop, git merge security, and finally git push. Thank you for your time, and I see you in the next lecture.